A big part of what makes an explosion really impactful and realistic is the shockwave element. So if you take a look at this finished and composited explosion shot here, you can see we have this kind of like dusty, smoky layer along the terrain here that just really emphasizes the power and impact of the explosion. If you saw this explosion shot without that shockwave, it wouldn't be nearly as effective. And next week we're going to get into these, combustible pyro effects like the explosion and the fire. But since we're talking about these density-based volumetric sims this week, like the destruction dust, it's also fitting to discuss the shockwave this week as well. So of course, you can wait until you do the explosion to do the shockwave. Typically, in production, we would do the explosion first and then the shockwave after that. But for the purposes of our learning here, you can feel free to work on this shockwave first if you would like. And sometimes in a production environment, you will get some previs animation for where these effects events happen. So for example, the animation department might put in just a noisy expanding sphere to indicate where the explosions are going to be and how they're timed and such. So you can feel free to add in your own, previs type animation if you want to do this shockwave before actually having the explosion available. So let's go ahead and start setting up the area of interest for this shockwave. So I've set up a geometry object here for that shockwave setup. And let's go ahead and object merge in the terrain. So I'll point that object merge to object / environment and out env low res. It's up to you if you want to use the low res or the high res for this. Either of them should work just fine. And let's also create an object merge for the creature as well. So I'll point that to object, creature ground, and render creature jolt. And we can merge both of those together just for display purposes. And just to make this a little bit nicer in the viewport, I'm going to go grab the colored version of this creature mesh instead. So I'll just go to our object merge for that creature and jump over to that. And then we have this colored version that we're using for display purposes here. And let's just add a null to reference that. This will be out creature jolt. Then let's just go back to our shockwave and update this object merge for that creature. It's a little bit visually nicer. And now we can carve out the area of interest in this terrain here. So let's drop in a bound and connect that to the creature. Perhaps template display that, and then drop in a Boolean intersect. Connect the environment to the first input of that Boolean intersect, the bound into the second, and we can just treat this environment as a surface instead of a solid object. So under set A, set it to treat as surface, and then display that. And you can see this is just carving out the area that's near the creature here. And we're going to be using this to do a few things. We're generating volumetric sources from this. We're going to be creating a collider object based on this as well. And we don't want this to change on every single frame. That can make things take a lot longer to process and cook geometry unnecessarily. I'm sure you've noticed a few times before me harping on this time-dependent network thing that you have to watch out for. So always try to avoid reevaluating your networks on every frame wherever you can avoid it. So let's drop in a time shift just before that bound and Control-Shift-Click to get rid of the expression on the frame. And I'm just going to set that to frame 80, which is about the frame at which our explosion happens. So you can see that little clock icon went away and this is no longer time dependent. And currently we're only trimming the terrain very close to the creature here. And we're going to want to source our shockwave volumes from a larger area and collide with a larger area as well. Now let's template display the bound, solid template our time shifted creature. And then on this bound, let's expand the padding a bit to include a wider area. So this looks like it should be a big enough region for that shockwave sim. And now let's just drop in a null after our Boolean intersect here. I'll call this env trim. And then to create the volumetric source, let's start by creating a circle, and I'll set the primitive type to NURBS curve, and let's display that. Let's just put our template display on the environment and the creature. And just to keep our display nice and efficient, I'm going to change this merge to point to the time shifted and frozen version of that creature Jolt, just so this isn't loading up cache frames just to display things. And then let's just set the center position of that circle to approximately where that creature is. And then set this to the ZX plane so that that's a flat curve, and we'll make this an open arc instead. And then adjust the arc angles so that we don't get an entire circle out of this curve here. I want to get something that's a bit more than a half circle here because I want this shockwave to kind of spread out and not just in a half circle in front of this creature's mouth here, but I want it to sort of push around the sides of the creature as well. So a bit more than a half circle should work well for this. And now let's drop in a transform SOP to position this a bit better. Connect that to our circle here. We'll use our usual Centroid transform presets. Let's rotate this to point the correct direction here, and then move this into place just under the mouth of this creature. Let's go into wireframe mode to get this just right here. And that might be a little bit hard to see in this wireframe screen capture here, but that positioning should work pretty well for us. And now we can start animating this circle to block out the shockwave. But before I start animating this transform here, I'm actually going to change this center point of that pivot to, instead of being the centroid of our input, I'll channel reference that to the center of this circle here. Because this is a semicircle, this actual center point parameter here is going to be the true center of that circle better than the centroid of the geometry is. So I'll copy that center parameter back in our transform. I'll paste in the relative reference there. And now we can go ahead and start animating that curve to block in the shape and progression of that shockwave. And now, after keyframing some expansion on this curve here to block in this shockwave motion, let's also ray this onto the surface of the terrain. So I'll drop in a ray SOP, connect the second input of the ray SOP to our trimmed environment. First input will be the curve that we've just animated. And for the direction, I'm going to set an explicit vector, and I'll get rid of the expression on this, Control-Shift-Click that, set the ray direction to -1, and part of our curve here is already underneath the terrain, so that's not going to be rayed properly. So oftentimes if you're doing a ray in a specific direction, you might want to just initially transform it in the opposite direction just to make sure that everything is on the correct side of that geometry. So I'll drop in another transform SOP just before this ray here, and I'll push our curve up quite a bit in Y. I'll just transform that up 20 units, so that's guaranteed to be above the terrain there. And this is still a little bit hard to see. It looks like this curve is still going underneath our geometry here. And that's likely because this is a NURBS curve, and it's only going to use a few points to define that smooth curve. So if we just display the curve itself without our template geometry, and we look at the points here, you can see this is only using a handful of points to define this NURBS curve. But this is still fine for now. Let's bring back our reference geometry. We're going to resample this curve a little bit later for some more resolution. So I'm not too worried about this being perfectly outside the geometry right now. But if you want to, you could temporarily set a negative lift direction on the ray stop, just so that we can see the curve a little bit better as we're animating it here. And let's do a flipbook to see what this looks like so far. Now, if you play back this animation, we have a nice rapid expansion on this, but this animation stops too abruptly. So we want to have a nice ease out fall off to this animation curve so that it just resolves a little bit more slowly at the end there. So let's go back to our transform that we're using to animate this. And oftentimes it's a little bit annoying for Houdini to display everything that you select in the viewport. Like you can see just by selecting the transform stop, I'm seeing that layered in with the node that I actually have displayed. So I often like to turn off that option. So if you go to this icon here, right click that, you can change this from show current operator to show display operator. And this can be particularly helpful if you're working with really heavy networks that are forcing things to cook just from selecting nodes. It can be easier to work when you change that option in some cases. So yes, back on this transform that we're using to do our animation, and I suppose I'll rename these for clarity. Call that one animation. I'll call this transform Y offset. And then we can shift click these parameters to bring them up in the animation editor. Space G will show the entire curve here. And it looks like we do have a relatively flat curve at the end of our animation here. You could select these curves, and instead of using Bezier, you could change this to ease out instead. And this will force a nice slowdown at the end of that animation. However, that can potentially cause a little bit of disconnect with the slopes on these curves here if you're using Bezier for one portion and the ease out for the other portion. That's not necessarily problematic, especially for fast animations like this one. So it's up to you if you want to just use an ease out like that. Or if we undo that and go back to the Bezier handles, then we can just adjust these handles manually as well. So if we drag this handle out like so, that's going to force a slope that's kind of similar to what we saw with the ease out setting. And in this particular case, I don't feel like we have to be super picky about getting this fall off curve exactly right. As long as we get a nice little slowdown at the end of the animation here, that's the key part. So something like this should work reasonably well. And most of this animation is coming from this scale on the X and Z axes. The uniform scale I'm using to just help control the overall size of this, but that's really only controlling the size for the first few frames here, so it's not quite as crucial. I only have uniform scale keyframes on frames 80 through 82, so I'm not going to worry too much about the curves on that. And similarly with the translate animation, I'm really only nudging this a few units in the first few frames of this because I'm super picky about this stuff. So feel free to adjust those curves as well, but it's really the main scale X and Z curves that are doing most of the work here. Now let's see what this looks like with the new fall off. And now if we check the adjusted animation, you can see there's a little bit more fall off to the end of this curve animation here. And it's kind of a subtle difference, but it does help a bit just to slow down the expansion a little bit toward the end there. And I really am just animating this over the course of about 7 frames here. And this is going to help drive the velocity of the simulation and control how quickly the shockwave density spreads. And once this curve animation stops, we are still going to get some expansion and motion carrying over into the simulation, so you don't have to animate your shockwave curve for the entire length of the shockwave's behavior. You just have to animate it for this initial primary emission here, long enough for the sim to pick up this velocity and behavior and take over from there. So now we can noise up this animation a little bit. I'll drop in an attribute noise just after that transform that's doing the animation. Crank up the amplitude a little bit. set the range to 0 centered, and the element size, I'll turn this up to a value of 10. And right now we're only getting a color noise on here, but we want to noise up the position, so change the attribute name to P. And I'm barely seeing any noise in this curve because, as I already pointed out, this is a very low resolution NURBS curve. So for noising up the points, we only really have a few points on that curve. So on the circle here, I'm going to go to the divisions, turn that up to 1000, which will allow us to have enough resolution for our noise to mean something, and that also gives us a better ray onto the surface of the terrain here. So now that we have this slightly more interesting and noised up curve here, let's go ahead and add some velocity to this. So after the ray stop, I'll just add in a trail, connect that up, and on the trail I'll set this to compute velocity, rename that for clarity. And now I'm going to build a surface from this curve position to where it was on the previous frame. So I'll drop in another trail stop, but I'm going to leave this one on its default settings, which will create a copy of the curve at the previous frame position. And then we can use an add stop to create a polygonal surface between them. So I'll drop in that add, and then go to polygons by group, and then under the add option, we'll set this to by attribute. But we don't currently have an ID attribute that this can use to match up the points. So I'm going to go back to just after we've created the curve here and drop in an enumerate stop. Set this to points, drop that just after the circle. And this will add some IDs to all those points on this attribute called index. And then back on our add stop here, under the attribute name, let's type in index. And now you can see it's building this surface in between the current frame position and the previous frame. And we can also display our velocity to make sure that's working correctly. And that looks all good. So this is starting to look like a good source for a shockwave. However, we're going to need a lot more resolution on here. So after the add stop, I'm going to drop in a resample and display that. Let's turn off our point trails. Check our resolution by turning on point display here. And this actually looks like a decent amount of resolution with the default amount of resampling here. And because these are just straight lines, let's once again noise this up a bit more. So drop in another attribute noise, set the name to P, range values will be 0 centered, and let's display that. Maybe turn up the element size a bit. And if you want to get really picky about this noise per axis, we could set different amplitudes for each axis here. So for example, if we only want to noise this up on the X and Z axes, we could perhaps turn the Y amplitude all the way down to 0, since we're going to be raying this onto the terrain once again anyway. So after this extra bit of noise breakup on the source here, let's push this right back onto the terrain once again. So just like before, I'm going to first transform this upward a bit, call this Y offset, and translate this up about 5 units this time. The amount of Y translation doesn't really matter as long as it's enough to safely keep our geometry out of intersection with the terrain. And then drop in another ray stop, connect our source to that. Second input of the ray will be our trimmed environment once again. Display that, and as before, the direction is going to be a vector. Get rid of this expression in there and set the vector to -1 in Y. And we do want our source to kind of stick to the terrain pretty well, but I don't necessarily want it to be perfectly flat onto the terrain everywhere. So we can use a bit more noise to kind of push this up in the Y direction. So dropping a new attribute noise after the ray stop and displaying that, set the attribute name to P. And for this one, I'm going to leave the range values as positive because I'm just trying to push the points upwards in Y to push it off the terrain in some areas. And since I just want to push this upwards off of the terrain, we don't really want to add the noise in the X and Z directions. So click this XYZ button and I'll set X and Z amplitudes to 0. And at this point you could either use the global amplitude here to turn that up or down, and you can also use the Y amplitude directly as well. It's up to you. And right now it's still kind of pushing this up everywhere. So we can have a bit more control over this and make that a little bit more patchy by turning on this Enable Remap Ramp option here. So by default, this is going to be a linear noise ramp from 0 to 1. So we can change this ramp to have less amplitude for a larger portion of our range here. And this just helps to keep those lower noise values closer to 0. And it's really kind of a subtle difference that you don't necessarily have to obsess over if you don't want to. But I think this remap ramp helps to keep this source a little bit more connected to the ground than it would be otherwise. So if you take a look at where these points meet the ground, without that ramp, you can see that all of these points are really getting pushed off of the surface quite a bit. And with that ramp in there, now we have our source points nicely connected to the terrain, and we still have this spiky detail that's offsetting it from the surface in places. And right now this noise is looking a bit spiky here. I think we can go with a larger element size for this. We'll try turning that element size up to 5. So this gives us some nicer shapes on there. The source still conforms nicely to the terrain, just with some extra shapely undulations in there. And sometimes when I apply noises like this, I like to do a fresh resample afterwards, just in case some areas get a bit stretched out and sparse. An extra resample can help to ensure as much resolution as we want in there. And because these are still forming these pretty clear lines in our geometry here, I'm going to jitter that as well. So drop in a point jitter. And that's a bit crazy and extreme by default here. So let's try turning that down. I'll try a scale of 0.5. And this is still a bit crazy, but this can actually still work quite well for our density volume source. And you could potentially do another resample after jittering the points like this, but I think this is actually going to work all right as it is. So I'm not going to obsess too much about resampling at every stage of our noise here. And now that we have this nice source spreading across the terrain here, we can go ahead and convert this to a volume that we'll feed into our sim. And to generate that source volume, I'm going to first set the density values on these points. And we're going to use an attribute noise to set these density values. And you could just set the density attribute directly, but sometimes I like to, instead of density, set this to the color so that I can see it a bit more easily in the viewport. And then I can rename that color to density afterwards. And right now we have a proper RGB color on all of these points assigned in this noise here, but we can make this a black and white color instead by changing the vector to float. And I actually think this element size is working pretty well for our density scale. It seems like a reasonable amount of splotchiness to our density values, but I don't want the density values to go all the way down to 0. So on this remap ramp, let's enable that again. And we don't need to add any points to this, but if you select the very first point, instead of letting these values range from 0 to 1, we can increase the lower value here, which is effectively the minimum density, and I'll turn that up a bit. So this still gives us some nice density coverage on this entire source, but it'll just break up those values a little bit, so it's not just a density of 1 everywhere. And now that we have the density values set on the color, let's rename that attribute to density. So drop in an attribute rename, and under the point tab, change the attribute from CD to density. and then drop in a volume rasterize attributes. And we want to rasterize both density and velocity. The voxel size, I'm going to set the same as the Pyro solver once we add that, but I'll just leave it on its defaults for now. Or perhaps I'll just turn this up a bit just in case it turns out very high res at the current voxel size and display this. And this currently looks pretty terrible, so we can try turning on the lighting in our scene so that we can see the volume a bit better, but this isn't looking very good either. So let's add a standard Houdini light to help illuminate this volume here. So I'll pin the viewport to our shockwave section here, and then go up to the object context, and let's go up to where our rendering setups are. And I'll just add in a new light here. Let's create a sunlight. Perhaps dial that down a bit. Maybe turn down the shadow intensity a little bit as well. And you can rotate this to your liking. So this is working a bit better like this. This looks a little bit weird here. I'm just going to assume that's some sort of a strange viewport glitch and ignore that for now. And this is currently looking quite blobby, and I want this to be a bit more defined than this. So on the particle scale, let's turn this down to create a finer source volume. And if you have a p-scale attribute on your source points, it will use that to determine the particle scale here, but with the way that we've set up our source, we don't have a p-scale attribute on here, so it's kind of up to us to set a particle scale that makes sense with the density of the points that we've input here. So I think that a particle scale just below 0.3 is looking pretty good. This looks nicely detailed, and we can get some more interesting details out of the actual simulation shaping and parameters. But just for our shockwave source, I think this is going to work quite well. Now at this point, it's up to you if you want to cache out this source so that it's not computing this on every frame as you're simulating it. And sometimes when you're doing volumetric sims, the creation of your source like this can be a bit slow, and it often is a very good idea to cache out these sources. In this particular case, I'm not too worried about it because this does look like it's creating this pretty fast. But if you want to, you could certainly drop in a file cache and write that to disk just to be safe.